Okay, in case you can calculate R in the way that R reluctance is 1 over mu times L over A. Okay, and the mu, of course, is mu 0 times mu R. And if we make 1 over reluctance, we have the permeance, which is in the case of the electrical circuit, we call it conductivity. Okay, conductivity in the electrical circuit also available in the other way. So the permeance rarely is used in the magnetic circuit, but usually we use the reluctance on the other way. So the first example is calculate the magnetomotive force, which is MMF, okay, required to produce the flux equal to 0.015 Weber when the air gap is 2.5 millimeter. Okay, so the length is given, the flux also given. Then ask you what is the MMF. So how we can calculate that one? In this way, let me clear this screen. Okay, in this way, as you can see, for the solution, first we have to calculate the B, which is flux intensity, then H, then MMF. So what was the B? B was mu. B is sorry. The B was phi over A. So the phi is given. The flux is 0.015. 0.015. The A The A is also given. Where is A? Okay. The effective area is 200 square centimeter. So we must, don't forget, we must use always the meter. So 200. So convert centimeter to meter is times by -2. So when it's a square, it's times -4. So the value is 0.17 Tesla. Next step is calculating H. So what is the formula for H? B equal mu H, correct? So H here is B, which is here, over mu. So is there any, is it mentioned any mu r? So when there is no mention about mu r, we have only mu 0. Okay, consider that one. So B is 0.75 over mu 0, which is 4 pi times 10 minus 7. Have you know that one from secondary school? Okay, so the value of H is given by 597,000 amp over meter. And finally, MMF, which is NI HL R phi. So which one you have? You know N? We don't know N, so we cannot use this one. We don't know I, so this one is removed. H, yes, I know H. You know L? Yes, the L is given 2.5 millimeter. Again, have to convert to centimeter. So this one can be used. What about the reluctance? Can we calculate the reluctance? Yes, we can calculate the reluctance. How? Using this formula 1 over mu 0 L over A. So if we using this formula, we can calculate the reluctance. Then the phi also given by here. So the other way to calculate that one is calculating the R, then times by phi. And finally, the same answer should be appear. Uh, it's the value for MMF is comes at the ampere turn. It's called ampere turn, which is N is a turn, I in amp. So series parallel of the reluctance is exactly the same as the resistance. So resistance, when they are connected in series, they will add to each other, the series connection, the same as reluctance. When they are connected in parallel, exactly the same as parallel connection of the resistance. They become in 1 over R equivalent, 1 over R1, R2, R3, whatever we have. Okay, very simple. Uh, so here, okay, here is an example of a system with two different